Assalamualaikum warahmatullahi wabarakatuh. Today, we want to talk about application of HVAC standard for commercial building in dining area of restaurant or hotel. Total guest is 30. We have 4 members in this group. Zikri Amin bin Rosmayudi, Muhammad Fawaz bin Muhammad Fazil, Muhammad Iman bin Khalid, Muhammad Imran bin Zaki. Introduction. Indoor and vehicle environment comfort technologies include heating, ventilation, and air conditioning. The purpose is to provide thermal comfort as well as acceptable indoor air quality. HVAC system design is a mechanical engineering post focus on thermodynamic, mechanical fluid, and heat transfer principle. We were given the task of creating the requirement for a restaurant with a capacity of roughly 30 people for our group project. We were also given the duty of calculating the refrigerant load and heat gain from various sources. To maintain a steady room temperature, dry bulb air, and humidity, the cooling load is reasonable. And latent rate heat must be evacuated from environment. Reasonable heat into environment causes the room air temperature to rise, while latent heat causes the room moisture content to rise. The cooling load in the building is affected by a variety of heat transfer mechanisms, including building, design, interior equipment, people, possibly exterior weather condition. The objective for this project is be able to maintain the set temperature level in the restaurant, keep power expense low and maintain a consistent internal temperature, improve restaurant comfort while ensuring energy efficiency. This is a design principle for our restaurant group project that roughly 30 people in the restaurant. This is assumption for this project. During the air conditioning design process, HVAC engineer look at variety of different factors, but the most important one is to consider are: number 1, type of air conditioning system; number 2, system size and available space; number 3, cooling load; number 4, energy efficiency; number 5, cost effectiveness; number 6, health and safety requirement. Different real estate and commercial business all have different requirements that an air conditioning system need to meet, and no single HVAC system will be the same one. It is designed to be fully optimized. Different systems include a variety of components, but as a standard, basic HVAC system incorporate boiler, air conditioning unit, energy sources, and vent into the design.
Hi, my name is Muhammad Imran bin Zaki, and today I want to present about our assumption made. A. Type of air conditioning system. The type of air conditioning system to be installed is one of the first variables to consider throughout the design phase. HVAC systems are all constructed with the same goal in mind to manage the temperature of a building. However, they are not all built in the same way. We expect a variety of air conditioning systems, each with its own sets of pros and cons. Different systems use different types of energy, and some are more compact than others. The system we select is as follows: ceiling cassette and wall mounted. B. System size and available space. Different systems make use of various quantities of space. Package systems, as previously stated, are the most compact. Larger commercial locations have more complex systems, so we typically recommend a split unit system. We must consider the unit's available space as well as its location. Furthermore, we anticipate that the results of calculations will match of the available space in the restaurant environment for our project. C. Cooling load. Cooling load is a critical estimate that designers like us must weigh when designing an air conditioning system. The cooling load of an air conditioning system is a measurement of how much heat it can remove from a building in particular amount of time. Because restaurants retain more heat and must be kept colder than usual, the air conditioning system must be capable of handling heavy cooling loads. If it can, the structure will be inefficient and heat all the time. We need to pay greater attention to matters like this in this circumstance. For our group project, the restaurant. E. Energy efficiency. When it comes to HVAC design, energy efficiency should be a major priority. Buildings with energy efficient systems can retain heat in the winter while remaining cool in the summer. We anticipate that it will reduce the energy consumption of air conditioning systems, lowering business properties' monthly electricity costs. Buildings should be appropriately insulated to provide optimal conditions for a functional HVAC systems if possible. Energy efficiency benefits the environment and it can help our company portray itself as more environmentally friendly and sustainable operation. E. Cost effectiveness. Cost is always a big factor in any commercial enterprise, especially when a large project is underway. As HVAC designers, we attempt to make our plans as cost-effective as possible while balancing the requirement to save money in the short term with the possibility to save money in the long run. Finally, rather than immediately cutting expense and selecting the greatest air conditioning unit on the market, we were able to determine cost effectiveness. It was all about designing a customized and efficient system that will save money for decades. F. Health and safety requirements. Commercial and industrial air conditioning systems must comply with strict health and safety regulations. Building requirements as well as guidelines from the Health and Safety Executive must be taken into consideration. Planning clearance may be required for our project, although this is dependent on the structure in question and the demands of the local government. Furthermore, before installation, a professional air conditioning system will guarantee that all health and safety regulations as well as other legal limits are fulfilled.
Hi, my name is Muhammad Fawaz bin Muhammad Fazil. Today I want to present about how to calculate interpretation and discussion. The first one is how to find CLTD. You can find in ASHRAE chapter 28, table 30. This is how to calculate CLTD. And the next one is how to find TM. Chapter in ASHRAE chapter 28, table 30, also 30. Next one is how to find CLTDC. CLTDC plus inside temperature minus inside temperature plus maximum outdoor temperature minus daily range divided by 2. The next one is how to find U. To find U is 112 mm concrete plus 15 mm cement. You can get 0.417 feet. The next one is how to find area, restaurant total area. This is how we find the total restaurant area. The next one is how to find dining area, length times width, kitchen length times width, and counter length times width. The next one is how to calculate door. 44.5 mm change to feet. We can get 0.146. The next one is how to calculate window. For example, dining room 822.668 feet times 30%. We can get 246.80 feet. The next one is counter 91 feet times 30%. We can get 27.3 feet. This one is how to find Q-wall dining room, Q-wall kitchen, Q-wall counter, not Q-wall, east Q-wall, south Q-wall, and west Q-wall. This one is how to find QS and Q-wall. We can find in ASHRAE chapter 28 table 3. And the next one is how to find people CLF chapter 28 table 37. CLF 12-hour working, we can get CLF 0.99. Next one is how to find internal cooling load. And how to find light 21, calculation light 21, and heat gain. Next one is how to calculate sensible heat. This is how to find sensible heat. TO means outside dry bulb indoor. TE means dry bulb indoor. And next one is WO is outside humidity ration. WI means indoor humidity ration. And the next one is how to calculate Q roof. This is the next one, how to find Q roof, and this is our total BTU per hour in our restaurant area.
Hello, Assalamualaikum. My name is Muhammad Imam bin Khalid. Today I will present about HVAC system purpose. We recommend using heating cassette and well-mounted unit based on the result of our calculation. We choose this unit due of the restaurant capacity in terms of the size and area. Furthermore, as compared to other unit, this unit can save on maintenance costs as well as customer electricity. We use a 2 horsepower well-mounted unit with 3 units and a 4 horsepower ceiling cassette unit with 5 units in our project. This is due to the outcome of our calculation with the area and they had included into the calculation. As a result, our overall count for the restaurant is 26 horsepower. We are certain that the spec we offer can provide a comfortable temperature and user certification with our recommendation. Lastly, consumer can also save costs by using the unit we recommend. For the next slide is about the cassette unit model benefit. First, it's rectangular because it has 4 wing flow and 4 swing coming out of it. Second, cool winds are blowing alternately from the left and right, as well as from the front and back. As a result, this unit can quickly cool the area in accordance with the area and horsepower. Third, this type also comes with its own water pump, which is used to pump water out of the yard from the interior cool on the unit. So, if you want to put the water pipe on the top of the unit, you can then no need for it to go straight down. Sensor that are extremely strong. With a dual sensor, the aircon cassette can enhance in its operation in decreasing the air temperature throughout a big room. The air conditioning system performance will be improved with the sensor, resulting in maximum refreshment. Next, there is a way to regulate the airflow. The cassette aircon is set up in such a way that it is easier to operate and the air temperature dispersion is more even and rapid. Obsession to airflow with proper control. The airflow from this air conditioner will be heavily disrupted with no leak. This can help you save both time and money by reducing the amount of electricity utilized. Lastly, the number of persons in the room is measured by a detector. This air conditioner infrared sensor can identify the number of persons in the room where it is mounted. When the sensor detects a big number of individuals, the air temperature is raised. Alternatively, when the sensor detects a small number of people, the air temperature is raised. The next slide is about the benefit of gas R14A. Firstly, the first type of gas utilized in A was R22. This gas is not harmful, but if the concentration in the air is too high, it might cause shortness of breath. Second, R14A gas is a new gas that it is used to replace R22 gas. It is an environmentally friendly gas that does not deplete the ozone layer. Third, in short, both R22 and R14A gas are required in air conditioning, and both contribute to the air conditioner and cooling successful operation. And the fourth is these two gases are primarily utilized for air conditioning and have comparable function and cooling. The chemical composition of R14A and R22 gas are very similar. And 5. The ozone layer is at risk of being penetrated by R22 gas, which will have a negative impact on the ecosystem and cause a greenhouse effect. As a result, R14A was created to replace R22 to better safeguard the environment. Lastly, R14A gas is a gas liquid mixture with a higher pressure than R22 gas. Therefore, air conditioner they use it will have a higher cooling efficiency than those that utilize R22 gas. Air conditioner that use R14A gas are more expensive than those that use R22 gas. This slide is about product information or brochure. And the diagram above is a catalog for a 4 horsepower cassette shielding unit. And the next diagram is catalog for a 2 horsepower wall mounted unit. For the appendix, we put 2 air conditioner we use like shielding cassette and wall mounted unit. And for the last slide is about reference. We use the link to find about advantage, about benefit, and about catalog of shielding cassette and wall mounted unit. Thank you for watching this video.